right, so let's take a look at our notes here. So this whole top part right here, that is just going through some vocabulary that we've already gone through before, but trying to just reinforce to you the importance of it. You got to make sure you know these words. So when I say that word domain, you got to know that that means my x values, also known as your input values sometimes. Your range is your y values, also known as your output values. The one I feel like a lot of people forget are your positive, which is above the x-axis, and your negative, which is below the x-axis. So we got to make sure we keep studying those ones. Those are the ones that most people forget. And then your max and your min. Maximum is the highest point on the graph. Minimum is your lowest point on the graph. So really nothing new there, just again going through your vocabulary for you. Now a new phrase we do have, but it's actually pretty an easy concept, is a linear function. So a linear function, according to that definition, is a function whose graph is a non-vertical line or part of a non-vertical line. So if we look at our three examples over here, these three are all a linear function because they create a straight line. Does anybody remember why our vertical line is not part of this? It's not even a function. It fails my vertical line test. If I were to draw my vertical line here, it would hit every single point going down. So a vertical line is not even a function. So our linear function, any other kind of line. Horizontal line, diagonal, anything along those lines. So then the other one is our nonlinear function. So it's just separated into two pieces. You got your linears, you got your nonlinears. So your nonlinears are basically anything that's not a straight line. So that first one, we got a curve. What kind of a function is this? Very good. So that's our quadratic function. But we call the shape of the graph a what? Parabola. The second one, that's a function you guys haven't learned yet. That's a cubic function. We don't really need to know our cubic function, but you can still tell that it's a nonlinear function because it still has a little bit of a curve to it. And then what's our function here? Absolute value. Now that one's nonlinear because really it's got two lines basically to it. So it's still a nonlinear function because it's got the two pieces and it makes that V shape. So let's take a look down here. What they want us to do is decide if each represents a linear function or a nonlinear function, and then explain. So we just got to say how we know it's that one. So this first one, is this linear or nonlinear? Nonlinear, how do we know? Not linear, it's not straight. Pretty easy one. How about for letter B? That one is linear. How do we know it's linear?
It's straight.
It is straight. And then how about our third one there?
No.
Non-linear. How do we know?
It's not straight.
It's not straight. Or we could say it is a curve instead of saying it's not straight. Either of those phrases works. So that's pretty easy. Linear, nonlinear. So let's take a look at the back. We have two other types of nonlinear functions that we're going to be graphing today. So our first one is g of x equals, what is this symbol here around my x? No.
Oh,
That x.
That's square root.
Square root. So this is a square root function. So what I want you to do right now is in your calculator, go under your y equals and type in your square root of x. And then graph, yep. There we go. Would that be linear or nonlinear?
Well, that's not. Would that
That would be nonlinear. It's got a little bit of a curve to it. Little bit of a curve going on there. So that one is actually a nonlinear function. So let's take a look at our table. Oh wait, I gotta fix my table. Hold on. 0, 1, bam. Now let's look at our table. If I go up in my table, our negatives are what? Errors. Why would our negatives be errors? Well, it does start at 0, but it starts at 0 because you can't take the square root of a negative number. I can't take the square root of negative 2. I can't take the square root of negative 4. So our negatives are going to have errors there. So somebody help me out. Look through the rest of your table. What do we get when we're at 4? X is 4, Y is 2, and then 9, 3. So let's plot our points. So I got 0, 0. 1, 1, 4, 2, 9, 3. Our graph will only have an arrow on the right side, not on the left side, because again, if I put an arrow on the left, it says it's going into the negatives, which we can't do. We can't have a negative in there. So is this graph increasing or decreasing? Increasing. And it's increasing for when x is greater than 0. Now for our end behavior, since we don't have an arrow on the left side, we don't have a left side end behavior. We only got a right side end behavior. So our right side of our graph there, it's slowly going which way, up or down? Doesn't really look like it. Kind of looks like it's going over there to the right, but our values are slowly going up. Do we have a max or a min? No. We got a minimum right there at the point 0, 0. Nothing's going to be lower than 0, 0. So now our domain range. This is the one function that we've been telling you about where your domain is not x is an element of the reals. It's the one function where it's going to happen. Because again, we can't have negative numbers. So our x has to be what? It can be 0, or it can be everything greater than 0. So our domain is x is greater than or equal to 0. And then how about for our range? What would our y's be? Our lowest y is... and then it's everything up from 0. So what sign would that be? Greater than. If we're going up, it's greater than. So y is greater than or equal to 0. And then is this graph positive or negative? Positive. It's never negative. That graph's always positive. All right. So then our next one. Does anybody know what we would call this sign around the x here? It looks a lot like the last one, but it's got a little 3 instead. Yeah, that's a cube root. When you get that little 3 in there, that makes it a cube root. So let's take a look at that graph. So let's go to our y equals, clear out our square root. To get your cube root, you're going to push the math button. And then you want choice 4. See, it's got the little 3 and then the square root sign. That's our cube root. And then you put your x in there. So we got the cube root of x. You got to practice. It's a slow little curve there. Is that linear or nonlinear? Nonlinear. It's still got a little curve. Kind of like snakes up a little bit around your 0. So if we look at our table, we got lots of decimals. So that's why in your notes, if you take a look, I've skipped over the decimals. You can do that. The only one you have to have decimals for are your exponential functions. You got to have at least 2 decimals, and then the rest whole numbers. So let's have you move around your table and fill in our chart here. Negative 8 for our x. What do we get? Negative 2. At 0, 1, and I got the other ones filled in. So So go ahead, plot your points. It's -8, -2. This graph would have arrows on both ends of it. We got to remember to label it h of x equals the cube root of x. So let's have you take a second, see which of these questions down here. Alright, so is this graph increasing or decreasing? Increasing. And it's increasing the whole time. So if we had to write the notation for it, that would be our XER, always increasing. We can do an end behavior for both sides this time. We've got arrows on both sides. So our left side is going which way? Down. And our right side is going up. Do we have a max or a min? We got none of them. No max, no min. That was a trick question for that one. What, max, min? Like this one up here had a minimum point. It's the lowest point, nothing's going to be lower than it. So if it has a max, like a lot of times our quadratics will have maxes, that's the highest point, nothing will ever be higher than it. So it's your maximum point. So our domain and our range. Domain, is that going to keep going on forever? Yeah, so our domain is going to be XER. X is an element of the reals. It's going to be every single x value. How about for our range? Our range is going to be YER. It's going to take a while, but eventually it could keep going on forever, and it's going to slowly work its way up and slowly work its way down, so it could be every number. And then here we have positive and we have negative. So those get split up into two pieces. So when x is greater than 0, so this way, are we positive or negative? Positive. Positive when x is greater than 0. So therefore, we're negative when? When x is less than 0. There we go.